Well, good morning, everybody. Happy Monday. I bet you never expected to see me on a Monday. Well, I wasn't able to be here Friday. I was kind of sick all week. So here I am on Monday. Uh, Today I wanted to give you a little taste of geology. This is only a bare introduction. So I just wanted to kind of give you a taste. Trust me, there's a lot more to it. Uh, our joke of the week, I was asked, what is your favorite dad joke? I give you a dad joke every week, so what is your favorite dad joke? Our Earth. Our Earth consists of 5 parts. Uh, the first part is the atmosphere, which are the gaseous layers. Uh, it exists in a graduated pressure. Uh, Everybody knows that. We talked about it before. I have some videos if you want to watch. Uh, Water. There are 18 major seas, oceans, and so forth. Plus, there are rivers, lakes, whatever. Uh, Water, by the way, also exists in a graduated pressure from the surface down to the bottom of wherever the bottom is. The crust is the uppermost solid layer of the uh, earth. The mantle, just below the crust, the mostly solid bulk of the earth's interior. When I was taking geology, they kind of called it like a plasticky uh, material, whichever you can think of it. It's not really solid, not really uh, liquid. So the outer core, you can see in the photo there, the outer core is a liquid layer just below the mantle. The motion of this liquid, which is caused by the Earth's rotation, produces Earth's magnetic field. The inner core is a solid ball, uh, nickel and iron, uh, and it is the center of the Earth, or at the center. Um, Let me also say all of these four solid parts of the Earth are also under graduated pressure. You don't see the pressure as much because they are not compressible. So again, I have videos that explain that. Uh, so these layers of the Earth are measured, they're observed repeatedly using seismic waves from various sources. So there are uh, artificially created seismic waves. Uh, Earthquakes produce seismic waves. Volcanoes produce seismic waves. Uh, any large event, I suppose if a meteor hit, it would produce seismic waves. Um, Tsunamis also produce seismic waves. And these seismic waves are different types of waves So they act differently in the different layers of the earth. Uh, so one type of wave bounces off of the outer core because the outer core is liquid. Uh, Another type of wave goes through to the inner core. But each wave is slowed down by the different types of materials. And so scientists are able to uh, clearly and uh, successfully measure this core. So we're talking about geology, and everybody knows geology means rocks. Here are the major types of rocks. First one is sedimentary. Uh, there are sediments deposited. You can see in this diagram, uh, sediments are deposited by processes such as moving water or wind, and these uh, sediments are become solid and are uh, become rocks. They're seen because they're uh, sometimes in there are big rocks, and that's called a conglomerate. There are smaller rocks, and there is sand. All of these are pressured into different types of sedimentary rocks. Second one is igneous rocks. Igneous rocks are formed by processes that bring molten rock to the Earth's surface. And we see that with volcanoes and such. Rock that breaks through to the surface is recognized by a dark color and small or no crystals. Um, what we would call lava that's hardened is usually scoria. Scoria is the black rock that has holes in it. Uh, it hardens quickly, and there are bubbles that burst, and that's what causes the holes. Uh, Basalt is another rock that breaks the surface. Basalt is very uh, dark black or dark gray, um, and there are no crystals in it. It's just a solid rock. Then there are rocks, or I'm calling them rocks, but it's more than that, uh, that stop below the surface before it forms a volcano. These form much larger crystals, and sometimes their erosion uh, allows them to be above the surface, and a lot of our rock formations you'll see are from these um, rock formations that stop below the surface. The last one is metamorphic rocks. Metamorphic rocks are caused by intense pressure. Uh, so igneous and sedimentary rocks both are put under high temperatures and pressure, and then they become metamorphic rocks. You can see these by like shale or slate. Uh, Slate forms from shale being put under pressure, and then slate has very fine layers. You can see the layers, you can break them off, and that's a metamorphic rock. Um, there are two essential processes that you need to know about. The first one is uniformism, and I'm not talking about the Unitarian Church. I'm talking about uniformism. Means that over long periods of time, and we're talking hundreds of thousands of years or millions of years, these geologic processes, which we've already talked about, volcanism, sedimentation, erosion, all of these things happen uniformly. So the sediments are laid down in a uniform manner. It's been this way since the beginning of the earth. Volcanoes tend to happen uniformly. We can see them here in this drawing. That's called the Ring of Fire, where volcanoes occur. You can see each one of those red dots is a volcano, and a lot of them occur around the geologic or continental plates, and that's why. But they always are in this uniform manner, so that if you look at the layers, they tell you what's been happening over these long periods of time. So those of you that believe the earth is only 6,000 years old and there's no proof that it's older, you have to realize that these processes that happen are over immense periods of time, and 6,000 years just doesn't cut it. Secondly, geologic layers are deposited with the oldest on the bottom, and then things are deposited on top of that. So the youngest layers are on the top. So if you go somewhere and look at a road cut, or if you look at a canyon like the Grand Canyon or somewhere, geologic layers are oldest on the bottom, and they get younger as you go up. And the reason there are layers is because something happened to change the formation. Okay, something happened, and once in a while you'll find them turned over on top of each other by an earthquake or something like that. And so when they're turned over, the younger layers might be in the middle or on the bottom or something. So that's geology for you. And I'm telling you, I just barely scratched the surface. There are college semesters more than what I've covered. So I'm just showing you enough for the good old flat earthers and these young earth creationists to just question their beliefs. If you'd like to know more about geology, let me know in the comments and I'll try to come up with some more to give you. Our joke of the week, if you'll remember, I was asked, what is your favorite dad joke? And I said, flat earth. So that was my favorite dad joke.